Hi guys, welcome back to another lesson. We're going to look at lesson 7, which is squares and like terms. And this is just another step in the area model moving back to or moving into the algebra portion. So on page 30 of our unit 4 workbook is where we are going to start in on lesson 7. Okay, so like I said, this is squares and like terms. So we start off here with a thinking out loud. So just a little bit of dialogue. Okay. Okay, so these three are using the area model to multiply x plus 3 and x plus 2. Michael has filled in 2x, 3x, and 6. Michael says, now all that's left is multiplying x by itself. When we do that, it's called squaring. So I guess we call it x squared, but I don't really get that. He fills in x squared. What does x squared even mean? She says, it's an x by x square. She draws an x by x square over here, x by x. All the lengths are the same. So it's actually a square, which is correct. What's the area of a 7 by 7 square? Okay, in order to find the area of an area, you take the length times the width. So if it's a square, you're just taking 7 times 7, which is 49. How about a square that has the measure z on each side? Z is just like an x and an x. X times x is x or xx. And we can just write x squared because that's what it represents. She says, then to fill the problem or to finish the problem, we'll put an x square there. Finish the problem, x plus 3 times x plus 2. We just add up the area and get x squared plus 2x plus 3x equals 6. Michael says we know 2x plus 3x is 5x. If the x is the number of marbles in our bucket, which that comes from unit or lesson 1 or unit 1 all the way in last semester, then it's like adding 2 buckets and 3 buckets. Elena says, so we can write x squared plus 5x plus 6. Are we done? What about the x squared plus 5? Can we rewrite that? Jay says, with 2x plus 3x, we knew that it had 2 buckets and 3 buckets. With x squared plus 5x, we know that we have 5 buckets, but as for x squared, well, x squared is the same as x times x, so that's like a bucket full of buckets. Okay, so we're just saying let's write the answer x squared plus 5x plus 6. Yeah, there are probably other ways to write it, but I don't think it'll get any simpler. So in our area model, 2x and 3x are alike, which is true. They're called like terms. They are both rectangles with the same number times x. And x squared is different because it's a square. I bet if there were another x squared, we could add those together. Yes. Okay. So what we're going to look at now, and what we looked at a little bit in the last section, were little tiles. They're called algebra tiles. And they have a different shape for the x squared versus the x terms. So the x squared is actually a square, and you can't add that to another rectangle. It'd be like adding apples and oranges. You can't add those together unless you change the label. So here in question 1, we have x plus 3, x plus 3. So you got x times x is x squared, x times 3 is 3x, x times 3 is 3x, and 3 times 3 is 9. So here, these yellow areas are the same shape. They're both rectangles. So you got x squared plus 6x, because 3 plus 3 is 6, plus 9. In number 2 here, we've got 2x times x So that's x squared. You could break this apart and put x and x. So you get x squared. So you have 2x squared. You have 4x. Here you have 3x, and here you have 6. So you got 4x plus 3x is 7x, and then you have your 6 right there. And we can change it. We can get rid of the lines. I like how they kept the colors though. For us, here we have x times x is x squared. X times 2 is 2x. X times 1 is just x. Y times 1 is y. And 2 times 1 is 2. Those are a little hard to see. But in here, we look for like terms. So there's an x squared. Here's an xy. Here's an xy. So you have 2xy. Notice I matched the colors up. Here we have a y squared. Here they want the yellow. So x and 2x, that makes 3x. Here they want like the pink color. So you got 2y and y, that's 3y. And then your constant term is a 2. So these colors and algebra tiles kind of help us out in doing this. But the quicker method here is just writing out the grid. So over here we have x plus 4 times x plus 5. Both models have 4 boxes, but only 3 terms. In the answer once you combine like terms. So we've got x and 4, x and 5. So you got x times x is x squared. X times 5 is 5x. 4 times x is 4x. And 4 times 5 is 20. Now, see, these have the same letters in them, so I can combine those. I can add them. They are like terms. So you got x squared plus 9x plus 20. Okay, here we go over to this one with the y plus 5 and y minus 8. So we got y and 5, y and negative 8. Okay, y times y is y squared. Y times 5 is 5y. Y times negative 8 is negative 8y. And 5 times negative 8 is negative 40. Okay, so you have y squared. 5 minus 8 is negative 3y minus 40. Okay. Draw an area model and use it to multiply. Okay, so we have b, and 7. So b times b is b squared. B times 7 is 7b. So that's it on that one, b squared plus 7b. Okay, notice we take whatever's out here times everything in here. So here we have b, 7 minus b. So b times 7 is 7b. B times negative b is negative b squared. So here we've got negative b squared plus 7b. I always like to put my squares first. Okay, the highest exponent we like to put first, but again, it doesn't matter. So x, 2x minus 3. And again, these are the things later on you're going to visualize maybe in your head. So you have x times 2x, 2x squared. X times negative 3 is negative 3x. So you get 2x squared minus 3x. Here's a little bit bigger one. You have b and 7. And 7 and negative b. So b times 7 is 7b. B times negative b is negative b squared. 7 times 7 is 49. And 7 times negative b is negative 7b. Okay, here you have, we'll start with negative b squared. And then 7b minus 7b, those go away. 7 minus 7 is 0, so you don't have to write that. And then you have plus 49. If x squared is x times x, what multiplication problem does it mean is meant by b plus 7 in parentheses squared? Well, with x squared, it means squared just means take it times itself that many times, in this case, twice. So here with b plus 7 squared, we're going to take b plus 7 times b plus 7. So you have b and 7, b and 7. Get your multiplication block set up. So b times b is b squared. B times 7 is 7b. B times 7 is 7b. And 7 times 7 is 49. So here we have b squared. We have 7b and 7b, so we can combine those. Those are like terms. So plus 14b plus 49. All right, moving to the discuss and write what you think. The area model diagrams for problems 9 and 10 each have 4 small rectangles, but the products they represent each have less than 4 terms. Why? Okay, so 7 and 10 here, we had, what it's saying is we had 4 little boxes in here. Okay, but why don't we have 4 terms? Well, that's because we had like terms. Both had 2 terms with just b's. Okay, here we had 7b and negative 7b. Here we had 7b and 7b. So those are like terms. Here is the area model that Jacob drew to multiply b times 7 minus b. How is this model the same or different from the one you drew in problem 7? He then wrote b times 7 minus b equals negative b squared plus 7b. Is he correct? Okay, well, we have b, 7, negative b. Notice we take the signs of those. So we got negative 7 or negative b squared, 7b. So he is correct. Okay. He is correct. And if we look at, no, well, it was problem 7 here. Problem 7 right here. So we wrote it b 7 times negative b, but he wrote negative b and then 7. So Jacob just switched the 7 and negative b. But he is right. He is correct, because he kept the correct signs. Okay, if he would have put b in negative 7, that would have been incorrect. But since he kept the right signs, he is correct. Okay, and you notice he's got negative b squared plus 7b. We have negative b squared plus 7b. Remember, I said we can write it in any order. These two drew a model to consider 2 multiplication problems. What problems were they working on, and what are the answers? Okay, so here we have r plus 9, r plus 9. Those are the same, so it'd be r plus 9 squared. And the answer here is r squared. Okay, these two are like terms, 9r, 9r. That makes 18r plus 81. Here we had k plus 6 and k minus 6, k squared. K times 6 is 6k. K times negative 6 is negative 6k. And 6 times negative 6 is minus 36. 6, so we add those together, we get k squared. 6k minus 6k, those go away, they cancel. And then you have minus 36. Okay, so sometimes you will have like terms that can combine into a bigger number, and then sometimes they go away and you won't even have that term over here in your answer. All right, that's where we're going to stop for this first part of lesson 7. You can go on to page 33 and begin working some of those practice problems. If you have questions, as always, reach out to me and I'll help you out. And thanks for watching.